Hi everyone, welcome back to our channel. I am Piyush and in today's video we are going to explore some of the most important and most basic data types such as strings, integers, floats and booleans, and we'll explore each of these in detail. So I'll come to VS Code and I'll create a new file called datatypes.py. So I'll click on this new file button and I'll create datatypes.py and make sure it has to be in lower camel case and I'll hit enter. So this file is now created. So a string is just a string of characters. So if I'll create a string like Piyush inside these two double quotes. So this word Piyush is comprised of these 6 characters joined together. And most importantly, whenever we create strings, we have to create them within the double quotes. And just like JavaScript, strings in Python are also indexed. By index, I mean each individual character has an index. For example, the first character will have an index of 0. Okay, and the second character will have an index 1 and so on. So if I want to fetch the first character from this string, I can do something like this. So I'll do, Piyush of 0. Alright, now if I click on this run button, I don't see any output yet as nothing will be printed to the console. So if I want to print it, I'll have to use the print method that I've covered in my previous video. Okay, so what I'll do is I'll use the print method here. So I'll do print inside parentheses. I'll keep this and now I'll clear this console and I'll click on this run button. So I get this output as P. And this might look like a little weird in case you are new to programming, but in all the languages, indexes always start with 0. So whether it is Java, JavaScript or Python, indexing always start with 0. And these are the indexes in this string. Okay, so P has index 0, I character has index 1 and the last character, which is H, has the index of 5. So the number we use inside the square brackets will determine which character is actually going to be pulled out from the string. So let me pull out the last character also. So for a string of length 6, the highest index will be 6 minus 1, which is going to be 5. So I'll be doing something like this. I'll be doing print and inside double quotes and I'll do Piyush and here I'll write 5, which is the last index. Okay, and now I'll clear this console and I'll hit the run button. So I get this output as H. So this Piyush of 5 is going to give me the output as H. So here's a secret trick I want to share with you that even a lot of seasoned Python developers also don't know, and that is that we can even use negative indexes. So just like we can use indexes like 0, 1, 2 and 5 being the highest index, similarly we can also use negative indexes like -1, -2 and so on. So -1 index means fetch the last character from the string, which is this one. Okay, so I'll comment out the first 2 lines and I'll use a negative index. So I'll do command and /, which will comment out these 2 codes. Okay, so now I'll write print and then I'll type double quotes. Inside double quotes, I'll type Piyush. Here I'll use square brackets and inside now I'm going to put a negative index of say -1. Alright, so I'll clear the console and I'll click on this run button and I get this output as H. So the same output which I was getting using index 5, positive index 5, I'm getting the same output using a negative index of -1. In other words, if I use positive index 5 or a negative index -1, we are going to get the same output. So by using an index, we can pull out any particular character of a string. So using a positive index, we move from left hand side to the right hand side, and by using a negative index, we move from the right hand side towards the left hand side. Now, in case you are wondering where we are actually going to use it, so it's going to be very useful as we'll be learning in our upcoming videos. Also, one important thing to note is that if I write a number like this, say I will write 456 inside these double quotes, then it is going to be treated as a string and not a number. So basically anything inside the double quotes is considered as a string in Python, or in other words, pieces of text. So if I try to add 2 strings that contain a number inside the double quotes, what do you think should happen? So do you think it is going to add 1 to 456 like we've added 2 numbers? Well, the output might amaze you. So I'll do something like this. Again, I'll use print. So I'm going to try to add these 2. So perfect. So I'll clear this console and I'll click on this run button. So I get this output as 4, 5, 6 and 1. So it is not addition, what I was actually expecting. So what has really happened is Python has joined these 2 strings together because of these double quotes, these ones. Okay, so in the world of programming, whether it is Java, JavaScript or Python, it is actually called as concatenation or string concatenation. So let me type a comment here after the hash symbol. So I'll type hash and then I'll type string concatenation. Alright, so this is actually a comment which we have written just for our understanding, and we want Python to simply ignore it. So we'll type a hash followed by whatever we want to type as a comment. So that's it about the string data type. Next, we have the integer data type. Okay, so what is an integer? It's a whole number that does not contain any decimal places. And in order to create an integer, we just type a number without anything else, not even double quotes as we saw earlier. So taking our previous example, if we remove the double quotes and now if we try to add them, this time they'll be added. So if I'll do something like this, I'll do print. I'm not using any double quotes now. I'm simply using 456 plus 1. And I'll clear this console and I'll hit the run button. And this time I get the desired output as 457. So these numbers got added, as this time they are not pieces of text or strings, but there's an actual number without the double quotes. So a number wrapped inside double quotes will become a string, while the same number without any double quotes will become an integer, or in other words, an integer. Now, as of 2024, there are 8 billion people in the world. So if we try to represent this number in Python, 8 billion is actually 8 followed by 9 zeros. So most of the times we like to make this number readable by inserting commas like this. So I can do something like this. I'll do print, I'll type 8, I'll do comma, I'll do 3 zeros followed by comma, again 3 zeros, comma, and then 3 zeros. Okay, let me remove this. It's no longer required. I'll clear the console. And now if I rerun this code, I'll not get the desired output. Okay, so Python interprets the commas as separators for multiple values. So it'll print the numbers individually, separated by spaces, which is not what we want. So to make it work, either we can remove the commas here, or instead we can actually replace the commas with an underscore, which will actually going to make it work. So let me replace the comma with an underscore. Okay, let me clear the console again and I'll hit the run button. And this time I get the desired output. Perfect. So using these underscores improves the readability of this number, which would have been very hard to read otherwise. But during the execution, they'll be completely ignored by Python. So the benefit is just for us humans to be able to visualize it more easily. Also in Python 3, integers are unbounded, which means they can be as large as they want. So I can give you a simple example. I'll type print and I'll type a very huge number. Okay, so it's a pretty huge number that I have typed. Okay, and I'll clear the console and I'll hit the run button and I'll see such a huge number, which is very hard to read actually. Okay, so what I'm trying to say is in Python, numbers can be extremely large. And as I mentioned earlier, all the whole numbers, no matter whether they are positive or negative, are called integers in programming. So what do you call them when they contain decimal places? Well, they are called as float, which is our next data type. So float is a shortcut for floating point numbers. So if I have a number like 4.678 and because it has a decimal point inside, it is a floating point number. Floats are typically used in situations where precision with decimal points is important. For instance, when you're working with currency calculations like calculating prices, discounts or interests, or maybe measurements such as distances, weights or temperatures where values often include fractions, or maybe even scientific data where any calculations that involve high precision like in physics, engineering or statistical data. So floats can be positive or negative. For example, it can be 1.5, 9.99 or minus 3.0. In short, whenever a number includes a fraction or decimal point or needs precision beyond a whole number, you'll likely use a float. And unlike integers, float numbers are not unbounded. So let me create a float number here. I'll hit enter here and then I'll type print and then I'll type 4.3. It's a huge number. I'll type 33333 and so on. Okay, and I'll keep on going. So if I run this code, I'll clear this console and I'll hit the run button and I see an output which says 4.3. Perfect. So here we see a much smaller version of that number, this number. Alright, so this is a level of precision that we run against floats. But in your day-to-day calculations, you shouldn't be worrying about this precision. But it's good to know that they are not infinitely precise. And floats take up more space in memory than integers, which is again very important to know. And lastly, we have a Boolean data type, which I believe is the simplest of all. It has just two possible values like true and false. So there cannot be any other third value. And note that if you're coming from languages like Java or JavaScript, Boolean values true and false are both in lowercase. But while in Python, they all are in uppercase. So true starts as a capital T and false starts as a capital false. All right. And they are not enclosed in double quotes or anything. So Boolean data types is used very frequently in your programs to test if something is true or if something is false, and for your program to respond accordingly. So that's it for this video. In case you haven't checked out my earlier videos, I would recommend you to watch them, as all these videos are structured and it's a full-fledged Python course from scratch. So all these videos also come with detailed notes which you can refer to refresh on the topics, and I'm sure you'll love them, and feel free to download them. Here is a Python playlist that I'll recommend you to access and bookmark it in your browser for easy access. And that's it. I have prepared notes for every Python video that I'm creating, and I would strongly recommend you to practice what you learned in this video. Just watching alone isn't going to help, as you'll forget it. So please do practice. And if you found this video helpful, please don't forget to give it a thumbs up and subscribe for more tutorials like this. Also, let me know in the comments if you have any questions or topics you would like me to cover. So thank you so much for watching, and I'll see you in the next video.